Welcome to this video. We are going to learn about uncertainty. So we're on page 13 in your notes. We're skipping this, and we're skipping this page. We're going to come back to all of that. It's important stuff. We want to do it, just not today. Okay. Uncertainty. Here's what uncertainty is. It's sometimes called measurement uncertainty, and it relates to measurements. Measurement uncertainty is another name you might see, as opposed to like philosophical uncertainty, right? Philosophical uncertainty is very different. This is measurement uncertainty. Numerically, uncertainty is, well, first of all, it's a value. See that? It's a number. It's an estimate of the maximum amount that a measurement could be off from the actual value. But wait a second, maximum amount that a measurement could be off from the actual? The amount a measurement is off from an actual value has a name. What is that called? The amount that a measurement differs from the actual value. That's called the error. So uncertainty is, did you see the word estimate? Notice that? It's an estimate of your maximum error. And that estimate includes an estimate of how much systematic and how much random error you think could exist in the measurement. This is a typo, isn't it? Exist. Oh, no, it's not. It's singular. Error is singular. Okay. The uncertainty can be expressed in three ways: absolute, fractional, percentage. So let's say there's a typo here. Let's say you take a measurement of, you measure the length of your car, and you find that distance, d, is 2.5 plus or minus 0.5 meters. Okay, that's the length of your car. And when you say plus or minus 0.5 meters, you're saying that I know I took a measurement, but look, things happen when you take measurements. Things go wrong. And there's lots of reasons why my measurement could be off. Maybe my meter stick has, it's cut off a little bit at the end, and so I know the measurement could be off some amount there. Maybe the lines are hard to read, and so I can't really tell where, what that last tick mark is. But things go wrong. But I know, even despite those things which go wrong, I still know that the measurement is somewhere in this range. What's the range? 2.5 meters plus 0.5 meters, which gives a total value of 3. That's the upper end of the range, and the lower end of the range is 2.5 meters minus 0.5 meters. Here's the operation, that many meters, which is 2. So even though things go wrong, I assert my measurement lies within this, I'm asserting that the true value lies within this range. Okay. Even though my measurement could be off, the true value is somewhere in there. Now, absolute uncertainty is, and by the way, this is the symbol for absolute uncertainty. The absolute uncertainty is delta D, and it's plus or minus 0.5 meters. So you notice it has units, and usually it has one sig fig, but sometimes it will have 2 sig figs. In a few rare circumstances will we give it 2, but most of the time 1 sig fig. The fractional uncertainty, what's that? Well, it's the absolute uncertainty divided by the measurement itself. So in this case, it's the 0.5 meters divided by the 2.5. 2.5, that's the measurement itself that we took. So by the way, when we talk about this thing here, this thing that we wrote down, 2.5, we called 2.5 meters, that's the measurement. 0.5 meters, that's the absolute uncertainty. Alright. And you can simplify this, right? You can cancel out the meters, they cross out. And then we can also take the 0.5 over 2.5 and write that as 1/5. So here's the fractional uncertainty, and you see it has no units. Finally, the percentage uncertainty is the exact same thing as the fractional uncertainty, except we make it a percentage. So what's 1/5 as a percentage? 20%. Okay, there's an important note. Fractional and percentage uncertainty, they both show how big the uncertainty is relative to the measurement itself, right? I mean, if you get an uncertainty of 10 centimeters, plus or minus 10 centimeters, if that's your absolute uncertainty, you might say that's a huge absolute uncertainty. But if the measurement is 1,000, or let's say 1,000,000 centimeters, then now all of a sudden this 10 doesn't seem so big. So it's really useful sometimes to talk about, how big is the uncertainty relative to the measurement itself. On the other hand, if you have an uncertainty of 10 centimeters, plus or minus 10 centimeters, if that's your uncertainty, your absolute uncertainty, and the measurement is 10 centimeters, then you are in big trouble. Your uncertainty is huge. It's exactly the same size as your measurement. So that would be big. So it's really useful then to talk about these things, which show, what do they show? The size of uncertainty relative to the measurement itself. And I'm going to abbreviate measurement. Okay. Oh, another rule, one last rule. Percentage uncertainty can have, well, there's a rule for rounding, but we'll look at that in a moment. Okay. So first, let's look at how we round absolute uncertainty. We're going to follow what typically happens, which is 1 sig fig. So absolute uncertainty, the value that has, the uncertainty which we express with units, the one that we give units to can only have 1 sig fig in almost every scenario. Okay, so let's watch and see how we can round the uncertainty and measurement for this rule. Step 1, round the absolute uncertainty first to its leftmost sig fig. Step 2, round the measurement next, so it's rounded to the same place or precision as the uncertainty. Okay, first, in this context, precise means a different thing from what we've learned already. Precision, usually you think of precision as like the bullseye, right? All the darts, all the attempts are at the same spot. But there's another meaning of this word precision. These two values are not equally precise. This one is more precise, the top one. So in another sense of the word, precision means what place have you rounded to? Have you rounded all the way to the 1,000th place? Or have you only rounded to the 10th place? So that's another way that we can talk about precision. It has two meanings, literally two meanings. Okay, so let's try this. First we round, number 1, first we round the absolute uncertainty. So it's going to be plus or minus, what is it? We want to give it 1 sig fig, round it to this place. The next digit is less than 5, so we leave this digit as a 1. We don't add 1. We don't make it 20, we leave it as 10. So plus or minus 10 grams. Where did we just round to? We just rounded to the tens place. Here's the tens place. So find the tens place and round to the same place on the measurement. Alright, so, well, that's the 5. Oh, it's already rounded to the tens place. How convenient. Okay. Alright, here's our next one. 760 point grams plus or minus 15 grams. This point, as a result of this point being here, this decimal point, all of these are significant figures. So currently, we have rounded this measurement to the units place, the ones place, right? Because of this decimal point being present. But we start out by rounding first. We round the uncertainty here to the leftmost sig fig. So round it to there. That's going to be rounding up to 20. Then we find the exact same place, the tens place, and we round there on the measurement, 760. This next one I want to show you because it's a little trickier. We round to the leftmost sig fig, right? The 9. But wait, we can't do that. As soon as we round to this place, we're moving up to 1, and that's exactly what you do. This is plus or minus 1 Kelvin. Not 1.0, because 1.0 would have 2 sig figs. And right now we're following the rule, just 1. So you round it to 1.0, and then you find the same place. We've rounded 1.0, that's the round it to 1, not 1.0, just 1. And then round 17.15 to the same place, to the 1 or units place. So you round to 17, not 18, because it's 17.15, not 17.55 or something higher. So take a moment, do the rest of this practice, and then when you finish that, come back to the video, and we're going to look at the bottom half. Okay, so I assume you finished this practice, right? Good practice here. Now on to percentage uncertainty. It has a rule for rounding as well. No units, hey, no units. Okay, here's the rule. If the percentage uncertainty, if it is bigger than 2%, then you round to the nearest whole number. And we'll say if it's bigger or equal to 2%, go to the nearest whole number. Right? So if it's 18.5%, round to the nearest whole number, 19. Why? Because it's bigger than 2. If it's under 2%, on the other hand, you give it 2 sig figs. So let me show an example from under 2%. Let's take this one right here. You want 2 sig figs, so round it to the first 2 sig figs. 1.2%. Okay. Pause the video, complete this practice.